Now we're going to look at another example, and this time we're going to calculate the proportions ourselves. In other words, raw data is given, okay, unlike in the previous example where the sample was given and the number of successes in the sample was also given. Here we're going to have to develop the number of successes ourselves. So here in this example we have two call centers, and one of the measures of how well the call center is operating is to look at the proportion of calls that are answered within 20 seconds. So here we are given a sample from the two call centers, and if a call was answered within 20 seconds you have a Y, and if the call is not answered within 20 seconds then we have a N there. So we want to develop a hypothesis test whether the two proportions of calls that are answered within 20 seconds are the same for the two call centers or not. So first we define what success here refers to. So calls answered within 20 seconds. So pi sub 1 is the proportion of calls answered within 20 seconds from call center 1, and the same for call center 2 will be pi sub 2. And we want to test whether these two proportions are same or not, equal or not equal. And say we want 5% level of confidence. So sample sizes, they are easy. You just say count call center 1 okay, and notice that the two samples are of the same size, so which means I can just simply copy this formula over and I'll get the corresponding. And the reason why we have a 0 here is because count only counts numeric values, so you have to use count A to count non-numeric values. So you can copy this over for call center 2. The number of successes is now we need to use count if. Okay, the range is that, and we want to count the number of Y's. Okay, now copy that. So then number of successes divided by the sample size will give you the proportion p sub 1 and p sub 2. So now if you sum, since we are doing a hypothesis test, we can do pooled value for p. So you add n sub 1 and n sub 2. You copy that formula down here, so that will give you sum of x sub 1 and x sub 2, and then you divide that by that will give you the pooled p bar. And the successes non-successes are all 5 or more, so no assumptions are required. So pooled estimate here is that. Okay. Now standard error is square root of p bar times 1 minus p bar times 1 over n sub 1 plus 1 over n sub 2. I need one more bracket. So that will give us the standard error. So then z stat is p bar sub 1 minus p bar sub 2 minus the value of the hypothesis, which is 0, so we can omit that part, divided by the standard error. So that will give us the z stat value. Okay. Critical value approach, so we use the t table value must be norm dot s dot inv. Okay, and Here we need the cumulative probability of the upper tail, so it will be 1 minus the upper tail area will be alpha over 2. Alpha over 2 is the upper tail area, 1 minus that is the cumulative probability corresponding with that tail area. So that gives us the z table value, and the conclusion is do not reject because the z stat value is less, the absolute value of the z stat is less than the upper z value. So this is a two-tailed test. So we need to look at the absolute value of the z calc. Now p-value, again it's a two-tailed test, and we have to find the tail area corresponding with the calculated z. So if you do norm dot s dot dist, okay, and then you give the absolute value of the z. It's a two-tailed test, so z could be positive or negative. So to be on the safe side, we always do the absolute value, comma 1. If we did that, then it will give you the cumulative area for a positive z. But what we want is the tail area, and since it's a two-tailed test, we have to multiply that tail area by 2. So what we need to do is to go 1 minus that cumulative area. So that will give us the tail area on the upper side, and then you have to multiply by 2 to make that into a true p-value. So that includes both the tails. So now we obviously cannot reject because the p-value is really large. Okay? And then we provide an interpretation. So we do not have sufficient evidence to conclude that the proportion of calls answered in 20 seconds, okay, is different for the two call centers. If we concluded they are different, then we will be committing type 1 error with a probability of 64.24%.